back, and now we want to talk about Archimedes' principle. So this idea was first put forth by a guy by the name of Archimedes, who was an ancient Greek. And so his principle says that an immersed body is going to be buoyed up by a force equal to the weight of the fluid that it displaces. So the general idea is that if you, let's say you've got a cup of water here, and then if you take your finger and you put it into that cup of water, you're going to push the water out of the way to make room for your finger. Okay, then when you take your finger back out of the water, then that hole is going to be filled back in with the water, because that water is going to exert a pressure back on that hole and fill it back in. So if you take an object and then you put it into water, then that's going to displace a certain amount of water. If you know the volume of the water that's displaced, you could multiply that by the density of the water, and then that would be the mass of the water that is displaced. Okay, then we know that the weight of the water is going to be the mass of the water times 9.8, little g. So then that's going to be the weight of the water that's going to be pushed out of the way whenever you put an object into the water. Well, that weight is what's going to be pushing up against the bottom of this object. And so depending on the weight of this object is either going to drop to the bottom, or it could float up to the surface, or it could actually stay where it's at. So let's do some examples of this. So example number 1 says that you have a 1 cubic centimeter block of iron, and you're going to submerge it into water, and then you're going to let go of it. What's going to happen to that block of iron? So you've got a 1 centimeter by 1 centimeter by 1 centimeter block of iron. So first we need to find the volume of that block. So it's 1 cubic centimeter, but the problem is that that is not the official metric unit. We need the cubic meter for our volume. So that means that we need to convert cubic centimeters into cubic meters, and then you get that number. Okay, then we need to find the mass of the iron. So I went to the internet and I found out what the density of iron is, and so I multiplied that by the volume of the iron, and then that tells me the mass of the iron in kilograms. Okay, then I need to find the weight of the cube. So that's going to be mg, where m is going to be the mass, and then g is the acceleration due to gravity, which is 9.8. And so I end up with the weight of the iron, the force that's going to be pulling down on that cube, is 0.077 newtons. Okay, now what we want to find out is what is the mass of the water that's going to be pushed out of the way. Well, the volume of the water pushed out of the way is exactly the same as the cube of iron that we put in there. So that's the same number. Okay, now to find the mass of the water, we need to know the density of water, which is 1,000. And then I multiply that by the volume of the water pushed out of the way. Okay, and now I need to find the weight of the water. And so I'm going to, again, take the mass of the water and then multiply it by 9.8, and then that will be the weight of the water. So that's what's going to be pushing up. And so notice that if I go back, here was the weight that's pushing down, and then here is the force that's pushing up, and you notice it's not enough. And so since the buoyant force is not strong enough, the weight of the object is going to pull it down to the bottom of the beaker or whatever it is. But let's compare that with this one. So this time we're going to take 1 cubic centimeter block of wood, and we're going to submerge it in water and then let it go, what's going to happen to it? So we need to find the volume of the wood, 1 cubic centimeter, and notice that's the same number that we used for the 1 cubic centimeter of iron. Now we need to find the mass of the wood. So I went to the internet and I looked up density of wood, and it turns out that the average density of wood is about 600. So I'll multiply that by the volume of the wood to get the mass of the wood, and then multiply that by 9.8 to find the weight of the wood. So now that is going to be the force pushing down on the wood. And then we're going to find the what is the buoyant force, and it's going to be the same as it was for the iron. So we find the mass of the water is going to be the density of the water times the volume of the water, and then multiply that by 9.8 to find the weight of the water pushed out of the way. And so now that's going to be the force pushing up. And now notice that this time that force is greater than the weight of the wood itself, so therefore that piece of wood is going to go up to the surface. Now if the two numbers had been exactly the same, then whatever the object was, it would remain stationary in the liquid. It would neither sink nor would it float. Okay, let's take a break, and when we come back, let's compare fluids with electricity.